Hello students, welcome back. Previously we studied some graphical presentation of data, and then we went through pie chart, bar chart, Pareto diagram, which are not that important, but these two are important: dot plot and stem and leaf display. The reason they were important, because just by looking at those charts you can retrieve the entire data set. That's why they were important. And also I can see the distribution. You have this concentration around here. Again, we have this concentration around over there. So those two are important. And the others were less important. Now let's go to even more important example, histogram. This is by far the most important, histogram. And the histogram is kind of related to the dot plots and stem and leaf display that we saw before, but they are more general because dot plots and stem and leaf display, you could picture them only in tens, but this one is a little bit more general. Let's go to the same example here. Okay, here's the data. And then if I sort the data, I get this. The lowest score is 33 and 58, 64, all the way over to 94. The same data set that we had been studying. And it's a hypothetical class. And then we ended up with the stem and leaf display. And I hope everybody can create stem and leaf display from this sorted data set, and also vice versa. And then when you have unsorted data, sorting it out is, well, it may take a bit of an effort, but if you have just 20-something data, sorting out manually is not going to be too difficult. Now we're going to talk about sorting out much bigger data with MS Excel. But that can wait. We're going to talk about it next week when you deal with presentation of numerical data. At this moment, let's just do it manually. Now, histograms are related to something called a frequency table. And this is an example of a frequency table. It consists of so-called class intervals where x value is between somewhere and somewhere. Between 30 and 40, between 40 and 50, between 50 and 60, between 60 and 70, and so on. Eventually between 90 and 100. Make sense? And then please look at this class interval. Less than or equal to the left-hand side. And then right-hand side is strictly less. Actually, this should be strictly less too. Nobody scored 100, so it's okay. And this is how the class intervals behave. Smaller number, less than or equal to, and for the larger number, strictly less. And the class interval sizes are all the same. Difference is 10, difference is 10, difference is 10, and so on. And at each class interval frequency, how many people are there? Let's see, between 30 and 40, there's one. Between 40 and 50, nobody there. Score 33 and then goes over to 58, so frequency is 0. And between 50 and 60, there's only one, 58. And between 60 and 70, there are 4, 64, 67, 67, and 69. You can get all those from the stem and leaf display as well. And then between 70 and 80, there are 10. Between 80 and 90, there are 6. Between 90 and 100, there's 1. Please check. And those are called frequencies. Basically, how many objects, how many items belong in the class intervals. Now for relative frequency, divide by total. The total, there are 23 students, so dividing by 23, we get all these decimals. This thing is called the frequency table. One more thing about class intervals. We have to have less than or equal to small number, not to the bigger number. And how do you remember? Think of this analogy. Suppose that you scored precisely 70. Your score is 70 precisely. Did you pass the course or not? Did you get C and pass the course, or did you get D and fail? If your score is precisely 70, it's C and you just passed. At least that's the way any course should be running. Without curving, before curving, that is. If you scored precisely 90, then you earned an A. It's not B. Precisely 90 is A. Now, with some curving, maybe you can get an A with 89 point something or even 88 points of something, but let's consider curving and everything out of the window. We are doing this just for exercise sake. So precisely 80 is A, precisely 90 is A, precisely 80 is B, precisely 70 is C, and so on. So equality should belong to the lower number so that you can move up to higher class. And by the same reason, we do not have equality here to the right-hand side. If you're equal to 80, then you don't belong here. Not in C group, you belong to B group. If you're precisely 90, you're not in B group, you're in A group, like that. So think of those class intervals to your own grade. Then you can associate why we have less than or equal to smaller numbers here and strict inequality to the bigger number there. Now, once you get those frequencies by appropriate counting, you're ready to draw a histogram. Class interval with same width, and we can take the height of each rectangle as either frequency or relative frequency. Here I use frequency. The width is 10, and then height goes to, well, the frequency. The width is 10, and height goes to the frequency, and so on. This kind of thing is called histogram. Now, what if you change the class interval? Suppose that you are in a little bit good mood, or maybe exam was a little bit difficult. So instead of giving, cutting everything by 10, you decided to cut at 12.5, a little bit more generous curving. According to this new scheme, so 87.5 or higher is A, and this time I have 2 A students, because previously I had the student who scored 88. Now this student is going to A range, so there are 2 A's. And then between 76 and 82, I have 12 students for B, and then next 12.5 and so on. So advantage of histogram is you can select the class interval width differently, and of course you have to get new table, but you can always draw histograms based upon whatever you're liking. Now if you go back to the stem and leaf display, it corresponds only to tens. So compared with this, you can produce more general and better picture with histograms. Now what if you go to 7.5? If you decide to do it that way, then you get this picture. In this case, 7.5, so 92.5 or higher is the highest, and maybe that's A plus, and then here this is A, I don't know whether this A, B, C, D example makes sense or not in this case. Anyway, you can select any class interval. That's the advantage of histogram. So, what's the characteristic here? Horizontally, we have class interval. Vertically, we have frequency or relative frequency. Relative frequency does not make any difference, just scaling. Do we have time for advanced histogram? Looks like we do, so let's discuss it. So the standard histogram is given by class intervals of same width. Same 10, same 12.5, same 7.5. Let me open those up again. Each rectangle has same width. That's standard. Now, in some cases, you are forced to deal with different class interval width. If you have choice, then you wouldn't do this. If you can choose your class intervals, then you'd select the same width so that you don't have to do this advanced histogram thingy. But sometimes you have to do that because somebody else already did it for you as far as class interval is concerned. Or by law, you have to do it that way, and then somehow you have to adjust yourself. In that case, you may have to consider these advanced histogram. In this case, frequency or relative frequency corresponds to not to the height, but to the area. We have this, and then between 30 and 50, we have uneven class intervals side, and between 50 and 60, and then 60 to 65, 65 to 70, 70 to 75. Now here I used height as the frequency. Height. So it gives you an illusion, and it's equally likely to find a student from 30 to 50 range and 50 to 60 over here. I mean, it looks like all these are equal distribution. But that's not true because we have only one student in this big interval was 20, and one student from 50 to 60, 10, and one student from 60 to 65. So this part should be more likely. And this one should be less likely. Indeed, this is correct histogram. This time, the frequency or relative frequency corresponds to area. You have to adjust your height accordingly so that area corresponds to the relative frequency. Relative frequency more typically, but sometimes frequency as well. Now, if you go back to standard histogram, you didn't really have to do this because interval widths are all the same. So area of each rectangle is proportional to the height. And then as for the proportional constant, that's no big deal. It's just a scaling, multiplying the same number. So just stretching the same way, no problem. That's why we could do this shortcut method, basically, so that we could set frequency or relative frequency to the height. As a matter of fact, frequency, or actually more precisely speaking, relative frequency corresponds to area all the time. It is area and it has always been the area. It's just that when the class intervals widths are the same, then area and height are proportional, so we could get away with just doing it with height. But as for the advanced histogram, please try to avoid it unless you know what you're doing. If you know what you're doing, then you can go ahead and use this advanced histogram. I do not recommend it unless you are headed towards many more math courses from this point on, and you are interested in advanced histograms anyway, then please go ahead and study. Otherwise, don't try this unless you know what you're doing.